I will hand them the microphone, so we don't have to repeat them. So did everyone get lunch?
No. Will some be provided?
We have passwords and hashes for you, and passphrases and hash. I can give you a pin code or two or something if you like.
Half brown, yeah. I get that.
I can tell you before I do the official introduction of Arnold here. When he submitted his whole proposal, I saw it immediately, and Arnold is the inventor of diceware. I saw the headline, Rock Salt, the method for securely storing and utilizing password validation data. And I also read the abstract, which you can see in the program as well. I don't know if you've read it. And honestly, Arnold, it doesn't say too much. I was very curious about this. So I'm no pressure. I'm really looking forward to this one. And I think quite a few other people are as well. So we are on time. Recording is ready? Yeah. I need to tell a few more jokes before we can start. I'm supposed to start at 2. Well, I came in here. I live in Bergen on the west coast of Norway, so English is not my mother tongue. But when I was flying over here, 3 long flights, I was actually asked by a person. He asked me, so why are you going to Las Vegas? Oh, it's a business trip. I said. Oh, what are you doing? Well, I'm co-organizing a conference. Okay. What about? Security. Okay, what kind of security? Well, my specialty is passwords and PIN codes and how people make them and remember them and forget about them and how they get access to their accounts again and anything you can relate to passwords. And he immediately goes, well, I always use the names of different parts of Rio de Janeiro with 2 or 3 digits at the end as my password. Do you think that's a good idea?
I like how he just volunteers.
And I'm like, and I look at this name tag and it's like, nah, not really. Not anymore, at least. And the fascinating thing is, if you have never tried this, and you should, and it's also a really, brilliant way to crash any party, really. Tell people that you are an password expert, or pretend to be a password expert. It's amazing how many people that they just need to confess their own password, and they also want to confess about how all the crappy passwords you can find with their employer. Like, it's insane. The root password in the entire organization is the name of the company, and our company is this. Okay, well, take note of that. I can give them a call. So you should try that if you haven't done so already. Tell people you're a password expert. See what happens. Pro tip. Perfect way of becoming single again as well. Steve.
Password inspector?
Password inspector. Oh, sounds nice. Well, time's up, and I will leave the stage to somebody who's going to talk about something we're looking forward to. So please welcome Arnold, the author of the diceware, to talk about Rock Salt.
Thank you all for coming out and not taking a nap after lunch. As I've been mentioned, I've been doing various things over the course of the last couple of decades to try and improve password usage. I started off with I actually posted something to sci.crypt asking people to send me their PGP passwords on a postcard on the theory that, don't put any identification any identifying information on the postcard, and quite a few people did, and I put out a little survey, and sure enough, most people were making really weak passwords. Diceware hex is I think one of the earliest, probably the earliest memory-intensive hash, and Diceware is doing very well. People have, on their own, translated it into a number of languages, the instructions, and there are currently Diceware word lists in 17 different languages. How many people here are familiar with Diceware, have seen it, or how many use it? Right, that's par for the course. Okay, another little thing I did was, this is a Diceware, we're taking a random set of 10 letters and producing a sentence. There's a lot of password advice to take a sentence and use the initial letters as the password. Problem is people are not very good at coming up with random sentences, and the distribution of letters at the beginning of words is not that random. This guarantees it's all uniformly distributed, and any 10 characters you want, you can get a sentence out of it to help you remember the password. It's not my day job. I've done many other different things. I've also, which is I've written the security chapters of a number of different dummies books, including Email for Dummies. It turns out when Hillary had her 50th birthday, she got a copy of Email for Dummies from her staff. I'm not making this up. It was reported at the time in Newsweek, so that she could send email to her daughter who was going off to college. And so anyway, it's all my fault. Okay, so today's problem, I keep looking, I have this thing right in front of me, I don't have to keep looking at the screen. Today's problem is protecting passwords in the enterprise. What I'm talking about today, Roxol, is intended to target enterprise scale systems. Big systems, many users, server farms, e-commerce, serious value at stake. There's a whole other class of passwords that are used to generate more or less directly cryptographic keys. The PGP and GPG use it. Disk encryption systems use it, Wi-Fi, and password managers and Bitcoin wallets. In those cases, I still say, pick systems that use good key stretching, use Diceware, and contrary to a lot of advice, write your password down, because that way you'll pick a password strong enough to remember it, and no, don't put it on a post-it note next to your screen. Okay, so back to the enterprises, which is the topic here. Enterprises have a problem. They have to store for every one of their users some information that can be used to validate a password when it's entered into the computer. And although many people keep talking about the death of passwords, they're not going away anytime soon. The enterprise can do things like throttling how many online login attempts happen per unit time, but there's this whole problem of offline attacks. The difficulty is that databases that are in use are very hard to protect. The databases are frequently stolen, and just encrypting, people will say, well, just encrypt the passwords. I think, as most of you know, it's not that simple. There have been many database breaches. Here's a few there's a list of them on Wikipedia. Companies that should know better, including RSA, have been hacked. It's very hard for middle-sized companies or any kind of enterprise that doesn't specialize in the topic to do an adequate job. I went to my local business school had a conference on computer security, and this is one of the slides that was up there, a couple of quotes. The favorite being, there are only two types of companies left in the United States, those that have been hacked and those that don't know they've been hacked. The other line at the bottom there, the best way to protect data is to get rid of all humans. Plan B is to train them. Plan B isn't working either. And I think we need to go to Plan C, and Plan C is, can we find a better way to protect passwords that are being stored? Okay, the existing methods are inadequate. Obviously, the worst case is just to store the raw password. There are still some people doing that, unfortunately, we find out. Simple hashing there are problems with that because you can build rainbow tables and whatnot. Salted hashing, computational intensive hashing, all these things are increasingly vulnerable because, as you'll see in the next slide, the computing power available to the attackers is just getting larger and larger. So people have come up with the idea of memory-intensive hashes that pushes the threshold a little higher for the attackers, but it's still expensive for large users of multi-user systems. They can't tie up a server for several seconds for every person who's trying to log in, or at least they could, but it's expensive. And we still have the problem that the weakest password can compromise the system, so that if you're once you're in, then you have the whole panoply of escalation attacks available to you. So and all these things, they help, but they don't really solve the problem. Keyed hashes was mentioned earlier today in the NIST presentation. It's a good solution, and in some sense you'll see rock salt has a lot in common with that, but it's still a single point of failure. We don't know how exactly we store these. The key for the hash, it's a very small value. We don't even know if it's stolen or not stolen. Okay. So there's an arms race going on here between the protectors of password validation data and the crackers are winning. And there are a bunch of reasons for that, one of which, of course, is our favorite Moore's Law. That's another thing. I guess Moore's Law and passwords have a lot in common. Their death is always being predicted. But they never seem to quite die. But another big driver of that is gaming. Computer gaming is a major driver of the industry and has focused a lot of development work on building very high-performance graphics processors. And modern graphics processors, it turns out, are just more than adequate for calculating the standard hash functions, which means that they are very good at attacking large numbers of, doing large numbers of password guesses at the same time. So even though the hash is salted, the GPUs can handle that. Memory-intensive hashes help, but again, GPUs are getting bigger. It's just a matter of time before they get big enough. And then finally, you've got the whole issue of botnets, which means that criminal elements have access to hundreds of thousands of computers that they can put to work on attacking password hashes if they get hold of them. And the cracking problem is, of course, massively paralleled. You can't think of a better solution for a better problem to attack with parallel computing. So this is the problem I'm trying to solve. Okay, and then the question is, at this point, there was a couple of earlier presentations on the keynote speaker from FTC and another presentation earlier in this room from NIST talking about increasing how to train people, how to get people to be more diligent in picking good passwords. What is a good password? There's a whole lot of churning about this. There's a recent story that Mark Zuckerberg of Facebook fame, his Twitter password turned out was hacked, and it turned out the password was ba ba ba. And if somebody at that level, who's a very bright guy, can be that sloppy in password picking, maybe we're trying to climb a hill that's a little bit too steep. You also have the problem that people reuse passwords, so damage from one attack can weaken other systems. And at some point, the problem is industry is trying to store this data. It really shouldn't be the responsibility of users to fix this problem. At some point, there has to be some way to solve this that is not dependent on users being ever more diligent in memorizing ever more longer passwords and even using diceware. Okay, and enterprise databases present an extra set of security challenges because they're in heavy use, and that means there are multiple applications from multiple computers, some of them accessing remotely. You can encrypting databases. I mean, there's this whole technology being developed called homographic encryption. Yeah, right, got that right. Anyway, where you can actually manipulate the data while it's still encrypted, but that's very cutting edge research, and it's not clear it will ever be really practical enough for day-to-day use. But in general, the problem with encrypting a database is that the encryption key has to be in the computer to access the database, and at some point this becomes sort of meaningless. Also, password databases have to be backed up. They have to be synchronized. All this adds more attack surface and more potential vulnerability. And the volume of password information is fairly small. I did a quick back of envelope calculation for 200 million users, the username plus hash plus salt, less than 10 gigabytes. And these days, 10 gigabytes, is too inadequate for my watch. I mean, it fits in your pocket, and if you take the thing apart, you can probably, swallow it, and it's just a very small amount of data physically. And then finally, the attacker doesn't need the entire file. The attacker gets can get a few hundred kilobytes of the password, or even a few K of the password. They have something to attack. Okay. There are a bunch of alternatives: two-factor and biometric. They're cumbersome. Adoption has been slow. The typical user has lots of accounts, so that right now, you can get a dongle for your bank or a dongle for your company thing, but how many dongles are you going to carry around? And as far as I know, there are no good standards yet for interoperable dongles, and that will no doubt present another whole level of attack. There was an earlier report, and I guess it was discussed also in this morning's discussion. NIST is, I love having, normally I try to avoid having too many acronyms, but it's fun to put a bunch of them in one bullet point. But NIST is depreciating using SMS, text messages for out-of-band two-factor authentication because, as it was pointed out this morning, there are too many people, like every clerk and every cell phone kiosk has the ability to generate an SMS card with a phony telephone number, so that the validation message that came through your phone could actually be diverted to somebody else's phone. So there's so many insecurities with that is, which was actually one of the things that actually starting to work. People are getting used to using their phones as an authenticator. It looks like that's like too dangerous. And I'd also point out that without secure password storage, then two-factor. If you have a leg that's on, or something that's standing on two legs, and you cut down one leg, you only have one leg. Without secure password storage, two-factor becomes one factor. Okay. So that brings us to what is rock salt, and it's somewhat similar to salted hashing or keyed hashing, but it uses something that is sort of my invention, which I call very large key cryptography. And I use very large key cryptography to transform the salt. And in doing so, I make something that's hard to steal and makes physical security feasible. So let's talk about what this VLK concept means. And the idea here is to have a key that is actually much larger than the expected volume of data that's going to be encrypted. Now, at first, that seems like crazy, right? I mean, I have this little equation that cipher keys are much smaller than one-time pads, which in turn are much smaller than very large keys. It seems paradoxical. One-time pad is enough. Once you have enough key bytes to encrypt every single character separately, what's the point of going beyond that? And the answer is there are in fact some advantages to it. One of which is you can get provable security, and I can get that. I think is going to be beyond the scope of this talk, but it's pretty easy to see why. But the most important thing for this talk is that you get a macroscopic key, a macroscopic secret, a secret that is actually physically big. Okay, and that means it can be physically defended. And short leaks of that key, if you use it properly, are inconsequential. Okay. The very large key, it would be random or possibly pseudo-random. That's a whole other discussion. It can be many terabytes, multiple solid-state disk modules. You compare this with ordinary keys, which can literally fit on T-shirts and have in the past. That's a complete program for decrypting DVDs. And of course, the whole side channel problem where you're talking about a few dozen bytes. It's very easy to, not easy, but it's very feasible to monitor power usage or monitor radio frequency emanations, or a whole bunch of different ways of getting keys that are being used over and over and over again. The one example that I'm aware of that's somewhat parallel to very large key cryptography is deniable cryptographic file systems, where you basically fill a disk with random stuff, and then when you write data into that disk, you do it in an encrypted way, and hopefully if the encryption system is indistinguishable from pure random data, nobody looking at the disk can tell what's data and what's nonsense. So that, and the point there being that you could then reveal part of what's there without revealing all of it. But so far, that's the only precedent for what I'm talking about that I know about. Okay, so let's go into a little bit more of the details, and it's not complicated at all, really, once you get past this point. Normal password verification using SALT. You look up the SALT, and look up the using the username as a key. You look up their stored hash and SALT in a database. You hash the password that was submitted with that SALT. Does that match the stored hash? If yes, you're in. If not, you're not in. Okay, everybody's familiar with this, I hope, at this point. Okay, rock salt is not that different. Again, you look up the stored hash and SALT in the database. And let me just go back a second here. Obviously, there's another step here which I'm not illustrating here, but it's straightforward, which is when you first set up the account, of course, you take the password, you hash it, and you generate a random SALT. You hash the password with that random SALT, and that's what gets stored away in the database. Okay. For rock salt, the main difference is you still look up the stored hash and SALT. You send the SALT to the rock salt server. The rock salt server uses the SALT as a seed for a deterministic random number generator, preferably cryptographically strong, that picks out some number of bytes, enough for, say, 64 bits or whatever. There's an engineering trade-offs there, but basically nothing much different from ordinary SALT. You assemble those bytes and return it to the password server as the rock salt. And the rock salt, then the server does a hash of that trial password with the rock salt. If it matches the stored hash, great, you allow access. If not, you don't. It's not that different. Here's a kind of a block diagram of how that works. Users, again, they're accessing the computer. PMM is the password management module, which is typically a dedicated server or servers in a enterprise environment. That in turn communicates to this black box that I have down the bottom, the rock salt server. It can either be via whatever the corporate network is, or even better with an optional direct link. The password management module also talks to directly that little database symbol down there with the little file folders. That's just the ordinary corporate database. I'm not doing anything different to protect the corporate database. Obviously, you want to protect it if you can, but as I pointed out earlier, that's hard to protect. The only thing that's being protected here is this very large key that is literally stored in a safe. And on the left there, you can see my little sketches of how that would work. The solid-state memories would be put into little modules that might actually be keyed to make it hard to, some interlocks would make it hard to, not impossible, but just hard, slow down anybody who got physical access from trying to copy what's in that, and then the whole thing being locked in a safe. And again, once you have something that is physically large enough to protect. There's a huge amount of technology out there that's well established. You can obviously use a Faraday cage to minimize any stray radiation. You can attach alarm system to this. One of the things about this is that the rock salt secret is static. So that means it doesn't require any periodic maintenance. The only reason to get in there is maybe an electronic failure that you have to replace one of the modules. So you can lock things in a safe. You can use, I don't know if everybody's familiar with it, but the whole concept of two-person integrity, where you have two different, it goes back to the, nuclear weapons launches, where you have to have two people turning a key to launch a missile, and certain government secrets actually require two people with a combination. That kind of technology can be used to ensure that no one insider can get at things. And again, with video surveillance, by making this thing big enough, the time required to copy the key or get meaningful amounts of data off the system is long enough that hopefully somebody would physically interrupt the process. You would presumably make more than one copy of this, so for an enterprise you might have several of them operating at the same time, and a few more of these modules kept in a vault somewhere as backups. There's tons of standards for both in terms of the electronic emissions from it and for the actual testing of safes. The NRI's laboratory has various standards. The General Services Administration has their Class 5 and Class 6 standards. There's all kinds of stuff out there that basically, these kinds of really fancy safes cost a couple $1,000s. If you think in terms of, again, an enterprise service situation, spending a lot of money to build a box like this that is secure, we're talking maybe, if we're selling this, tens, twenties of thousands of dollars, it's typical of internet appliances, and it's small compared to the what's at risk by having password data stolen. Another thing that can be used to protect us, since we do obviously you have to have some electronic communication with this very large key, is to use a data guard. My data guard basically is a microprocessor or even an ASIC or FPGA that's just designed to pass only certain messages and at a rate-limited level, because the amount of data traffic required for the day-to-day ongoing minute-by-minute password verification is much less than the data rate needed to exfiltrate enough of that very large key to cause damage. These data guards can be made, they don't need an operating system. They can be very simple, easily audited software. There's a lot of, I think you can now actually get stuff that will take Haskell code and translate it into microprocessors. So you can have stuff that can be subject to proof systems. And you can actually have a series of different guards along the way. Some of which just limit the data, others of which we'll talk about in a second, make certain statistical tests to see if the things come under other kinds of attack. The alternative, the major alternative that I'm aware of is creating a separate database for password verification. Somebody asked me a question on the Pureless system. The name is 1337 Mark. Are we talking about a secure enclave for the passwords? And the problem with that is it complicates backup and synchronization of databases. Large enterprises may need to have more than one server and more than one password database to allow multi-continent operation of their business. All that synchronization creates more places where data can be stolen. And again, a small leak can cause compromises. Okay. So again, the big advantage of this is, from the user's perspective, is that we're back to passwords that are short enough that really people are comfortable with them. You still obviously have to limit or throttle failed login attempts so that a remote system doesn't sit there cranking away, trying to log in over and over again. But that's well-established technology. People do that, and it doesn't require any changes to existing practice. The only thing you really have to avoid is obvious passwords, something you can get from the Facebook account or some social engineering, pet names and stuff like that. Even the old, I don't know how many people remember the old AOL discs that used to be handed out, but they'd come in a little card and there'd be like a little, your password on it that was 2 words with a special character in between. That would be more than adequate for this kind of thing. Even ba 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 would be fine. Okay. So potential attacks, obvious one, physical security violation. Again, the use of alarm systems and monitoring systems. Again, since this doesn't require anybody to access the system on a normal basis, one can be fairly strict in terms of using secure practices that are standard in industry. I think one of the major concerns would be malware that somebody sitting inside the corporate system and using the rock salt server to periodically, check passwords and accumulate them and exfiltrate those out. I think the answer to that one, there's a bunch of different answers there, one of which is to really have a secure link between the password server and the rock salt server, keeping track of how many requests and so on, maybe even add some canary passwords that would not normally be accessed. The basic thing to think about is that really if the software that's actually doing the password checking can be compromised, all the attacker has to do is get the passwords as they're entered. So you have to assume that for any kind of system that we have at least some integrity in the actual password verification software itself. Again, easy to guess passwords. I had put down using dictionaries to prevent users from selecting passwords that are too obvious. Actually, there was an interesting comment made earlier that actually may be counterproductive, because when somebody types in Rumpelstiltskin as their password and it gets rejected, they'll just type in Rumpelstiltskin 1, and that actually creates a set of passwords that are good ones to start trying. But again, there may be some training required here, or actually it may be desirable not to look at a dictionary necessarily, but look at things that you already know about the user, so that, for example, they don't use their username or the company's name or their personal name as their password. But this is, again, is a much easier challenge in terms of training people to just get them to not use things that are really closely, that somebody can easily guess about them. And of course, any password system is vulnerable to that kind of attack. So summing up, the advantages of rock salt: it's dependable, it's engineered, it can be proven from, its security can be proven from first principles. It eliminates the arms race because attackers don't get the opportunity to do offline password guessing, even if they get hold of the database. It's even quantum computing resistant, less burden on users. The changes to existing password management practices are very small. One has to set up this communication link and probably have some field in the database that tells you rock salt is enabled, but that's about it. And again, the password data itself, the verification data, just becomes part of the ordinary corporate database. It can be backed up, it can be handled no differently from any other user account information. The transition is easy. We've thought about how to fall, if people try this and they don't like it, coming up with a way to fall back to older systems if necessary. I think there's a confidence building step required here. But the bottom line is a lot less risk and liability for the enterprise, and of course, a lot less burden on users. Limitations: it's too cumbersome, I think, for small or personal operations. Again, using key derivation functions is probably the best bet for that. It's not a solution, as I said earlier, for passwords that are used to derive a cryptographic key. You can't use password hashes as a credential to share with other organizations or other parts of the organization, and that's not a good idea anyway. Business problems, obviously this is a new idea. Getting people to try it will be interesting. There are a lot of questions there, but that's maybe for another discussion. Finally, I want to say that this is not necessarily the most elegant solution. The idea of building this, terabytes and terabytes of information just to protect passwords seems clumsy, but I believe it works and nothing else does. And those of you who remember Raiders of the Lost Ark might remember this particular scene. Okay. Any questions?
I don't think there are any questions, so we can just... Matt. The honor of starting this one.
Okay, so this sounds like it has a lot of similarities to blind hashing by tap link, which is they coined the term security through obesity by essentially having a very large hash database or a database that they would use in the hashing process.
And maybe, I haven't seen it, I should look for it.
Okay, cool, thanks.
This is probably just my own brain fart because you definitely went into detail, but why is it that, how is the RSS server able to verify all these passwords if the trusted module is stored separately and securely?
Right, all the RSS server does, this is a good question. Let me see if I can get back to the little picture. All the RSS server does is effectively create a way of transforming the hash that was stored in the database to a different, the salt that was stored in the database, transferring the salt that was stored in the database to a different salt. And it does it in a way that an outside attacker has no way of knowing what that salt value is. So even though they get the salt that was in the database, they can't use that to calculate the hash that's stored in the database.
So is it a salt token? How is that different from a salting token that represents the actual salt?
I'm not sure it is. I'm not sure. The difference here only is that by using a very large key, you can defend this process. That's the novelty. A keyed hash would do this, right? But a keyed hash, you have a 128-bit or 256-bit key in that hash. You have maybe you're using a hardware security module. Maybe somebody develops a new side channel attack to that module. It's a single point. It's a very, very fragile single point of failure. The novelty here is using this very large key.
Can you go back one frame or slide? So, is that accurate?
I think so. Maybe if
Okay, so there's a salt in the database.
Right.
Then you take that salt, give it to the rock salt server.
Right.
It returns a salt for you.
It returns a different value.
Yeah. And then you hash that.
Yeah.
So what's stopping someone from getting into the server, grabbing all the salts, requesting the rock salt server for all of those?
Right, and I mentioned that earlier, and that is. Let me see if we can get down to that. The main thing is to use a data guard that limits the rate at which you do this, and then also maybe has statistical tests that say, there seems to be a large number of. I believe you can get statistical patterns for what normal access is, and to distinguish between a systematic search. But yes, and then the other point is that in this whole system, I'm assuming that the server that is actually doing the password, when you attempt to log in, a password field gets sent to some server somewhere. That server then tells the rest of the system, yep, it's okay, or no, it's not okay, right? If that server can be compromised, you don't have to do anything more fancy than save all the passwords that get typed in. So we have to assume that there's the ability to make that server reliable. That has to be trustworthy, because if it isn't trustworthy, like I say, you just grab the passwords directly. Why bother with anything else? So if you can make that reliable, that becomes the only thing that has the ability to talk to the rock salt server. It has a secure link, so the rock salt server is looking for its signed messages from it, whatever, there's a variety of ways you can secure that link, but the idea is to make that link secure so that it's not easy for somebody to infiltrate software and do exactly what you're saying. But that of course, is the trick that has to be prevented.
So it sounds like your big win here is that you're protecting from the particular attack, like offline attacks. So
Right.
somebody can't just get to the database and then do as many offline attacks with as many like GPUs as they possibly can.
Right.
And you still have a bunch of the same problems that existing systems do, but you've really locked down the offline
Right.
attacks.
But if you were here earlier, I mean, it's the offline attack that's driving everybody crazy. I don't know if you heard the keynote, but the young woman who was speaking was talking about, the fact that, large numbers of people are not with the requirements for people to change passwords. They're using closely related passwords. So once you get their password or one or two examples of their password, you can figure out their whole practice and maybe try it out on other systems. The whole thing becomes an arms race, and the arms race is not in the favor of people trying to defend.
So it sounds like the difference here between what you're doing, I mean, there are obviously some mathematical differences between what you're doing and the idea of doing a keyed HMAC on the hash. But aside from that, it sounds like the fundamental difference here is that the secret that you're using is fundamentally larger than the secret that might necessarily be used in say, an HSM for doing an HMAC. Is that correct?
That's correct. That's exactly
Okay, so-
exactly correct.
So basically, your assertion here is that it's easier to protect a big key than it is to protect a smaller key.
Yes.
And I guess I don't accept that that's necessarily the case. I mean, a lot of the things that you're talking about doing here in terms of protecting the rock salt server are things that you could do just as easily on an HSM to protect the HMAC process.
Right, but how, again, how would you, for example, take for example the question of side channel attacks. With an HSM, you could get, if somebody came into the facility, set up a monitoring thing, which, the cleaning person or whatever, got we're talking about 32 bytes of data here. There's no way you could have any confidence that never happened. Whereas with this, you have it's an engineering thing. You have some engineering ability to say, I know what the amount of data is. I know solid-state drives actually can't be read out very quickly. You can actually so you have a whole bunch of again, so it's a defense in depth engineering solution that says, I at least have the ability to get some confidence. I can review my monitoring tapes. I can do a whole bunch of things to say that that data has not been stolen with some confidence. Whereas with an HSM, maybe.
Well, we'll just leave it and say that I think there are ways to protect against those side channel attacks in HSMs as well. The other part of this, though, is, unless I missed it, you didn't say anything about the size of the salt that you were using here, because
Well, I
in
think
the other case we had perhaps a 32-bit salt, which is enough in order to essentially solve the deduplication problem. Here you're asking for an additional level of security from it that would require a much longer salt, I presume.
Well, I didn't talk about it. I can. The short answer is there are a couple of things you want to do. One of which is there are a couple of engineering trade-offs. It's a salt that's 64-bit or 128 bits is not a great expense in terms of databases and stuff like that. And then the rock salt. Sorry, not even the question of databases. In terms of transmitting data back and forth. And there's actually a bunch of trade-offs I've considered here, but one of the reasons you want it a little bit bigger is there's always, I mentioned that small amounts of data leaked from the very large key don't do damage. The reason they don't do damage is that probability would be you might get 1 or 2 or 3 bytes. So you want to have the salt large enough so that 1 or 2 or 3 bytes being compromised doesn't reduce its efficiency. But it's not a huge increase in size. And there's some actually other options here too, one of which is actually a different mode, which I talk about in my paper, is sending the password to the rock salt server and the hash, and the salt, and letting the rock salt server do all the calculation, then just only send back a single bit which says yes or no. So that would even further reduce the amount of data that could leak out of the server. But these are engineering trade-offs, but they're not in my opinion, they're not that difficult or dramatic.
Last one.
So you mentioned a deterministic random number generator on the previous slide.
Right.
Is there any security concerns about that random number generator that you would have to think about specifically with this problem, where you have a very large key and you're trying to prevent exfiltration of even of a smaller key?
Really any decent deterministic random number generator will do. Think about what's going on. You're sending the salt, which becomes the key, the seed for that deterministic random number generator. That is going to pick out 32 or 64 bytes out of this entire 100 terabyte, 10 terabyte, whatever memory, and then that string of bytes will be the rock salt. So the secrecy is simply the fact that the attacker has no idea what's in that very large key. And in fact, you can then begin to do basic statistics given the volume of users and what is the probability of any one byte being used even twice. And you can make that relatively small so that in reality, the vast majority of bytes that make up that key will never have been seen before. So that's really where the security comes from.
Okay, I think we'll stop it there. Arnold will be around afterwards as well, outside in the hallway. So now we'll do a short break until 3 o'clock. And next speaker up is Jeff Goldberg from Agile Bits, makers of 1Password. See you back then. Thank you.
Ira Victor from Cyber Jungle Radio.
Hi, please mention.
Thank you. And speaking of the talk at Cambridge in December, I'm just assuming all of you have either watched that talk or read all the slides, so I don't actually have to explain what this two-secret key derivation is, and I can just talk about how we communicate this to users. Right? Yeah, sure. OK, so two of the three J's are here.
Jesse, please stand up.
Right here, I'm wearing the same dress. I'm really
Jesse Hurwitz on Twitter.
Yes, Julie is not here. That's me at the end, and we are being protected by Umbrella Bear, a bit of an inside joke. OK, anyway, so two-secret key derivation. We've been struggling with names for this thing, but this is the flavor of the week. Basically, what we're doing is in deriving the keys that are used for both authenticating with the 1Password server, now that we've actually have started running a service, and the keys that are used to decrypt the key encryption key that's used for encrypting your private key from your personal key set. That's way too many keys. So in deriving the keys that you actually need to unlock stuff, we take two user secrets, a master password and something that we've called an account key, and I have no idea why we call it that. So a master password is something that's more or less created by the user. It's stored only in the user's head, which makes it difficult to steal. I mean, torture's one way, but it is, it's created by, it's a human-created password. They need to remember it. They need to type it. So it is not so difficult to guess. Now, the account key is created randomly by the client, 128 bits. It is stored only on the user's device. It is possible to steal because it's stored on the user's device before they actually get their keys for encrypting their data. And it's pretty much impossible to guess. Now, the reason for this is that we don't want to store hashes that, if stolen, could be used in any kind of offline attack. That is the goal of this thing. What we store on the server, as I said, until recently, we never touched any user data whatsoever. And we liked that, and there were reasons for that. So we don't want to have anything worth stealing, anything that we could work on cracking if we were compelled or just decided to turn evil. No, it's not going to happen. Anyway, so by blending in this other high entropy user secret, this account key, then what we're storing server side is just basically uncrackable. Now, it's not actually a hash. It's an SRP verifier, but the principle still applies. OK. Now, I said in Cambridge, I talked about the technology, the key derivation, all of that stuff. My concern here is we are presenting a new kind of secret to users. And we kind of hope that they behave in ways that help their security instead of harm their own interests. Now, so we've got this new kind of secret. It's unfamiliar. So the questions are, how do we get users to treat it properly? How can we help users not to lose it? Because if they lose, if they forget their master password or they lose their account key, that's it. There's no way to derive those keys that are used as key encryption keys. So now we've added a new way that people can get totally locked out of their data by losing their account keys. So it's sort of the user, it's the helping the user, or what we attempt to do, that is really the topic of this talk. OK, so Chain of the Psycho Dog. She's really sweet, except for when she isn't. Catches frisbees, balls. We have no idea of who trained her to do this. But anyway, so she's going to be our team leader. And so what you're going to see is a video that shows a first sign in and a first sign up for 1Password for Teams. And so we're just going to go through a lot of steps here. But I think that, so we'll see her do lots of things. And OK, so here's a video. Sorry, Chain of the Psycho Dog. This is Morgan, the other member of the family. And yeah, she's the sane one. OK, so although we're going to talk about teams, she's going to create a family because the control panel and screens are a little simpler for those. OK, so go through a normal sign up. She selects a family name, and she has to give her email address. And I decided not to expose her real email address, and I was too lazy to set up a special account, so there we go. And so she will be given a URL based on that name, and there we go. She gets told that she'll get some email. There's her email. Real name. And this, by the way, is me speeding up the video because I type really slowly, but Chaina types even slower. OK, first presentation of 2 secrets. Protect your data. And now you are given your account key. Now, the first part of it is non-secret information, but the bulk of it is secret. So there's actually account identifier at the beginning of it. And so it was selectable. You saw a copy operation. She saved it someplace. OK. Now, oh, wow, this is going way too fast.
Speak faster.
OK. But as you saw, there was actually a Diceware-like generator to offer people help in choosing master passwords. She practices that. Oops, she typed it in wrong because she thought it was cake instead of cape as the last word. There we go. And now we are generating public-private key pairs and a bunch of other stuff. And her first task she's given is to save her emergency kit. The emergency kit contains all the non-secret information, her account key, and a nice space to actually write in your master password and a QR code that we'll get to later. You're encouraged to write down your master password, put this piece of paper in someplace safe. OK, let's just set up stuff for the account. Oh, well, they're dogs, OK. OK, so just so that we have some data to look at, Chaina creates some data. Rabbits are faster than they look. As much as I hate to say it, we may need to cooperate instead of compete. Yay, oops, but she saved this to her personal vault. This is something that should be shared with every member of the family. So 1Password has these different vaults with different properties. So she's now put that into the shared vault. OK, so that was a lot that we've seen there. Because this first run through and then also adding data is a bit much. But this means that at the moment, the only place she has her account key is in that emergency kit that we hope that she saved, and in the local storage of the browser that she used for doing this. And remember, the account key is absolutely necessary for deriving these keys. So what we would like her to do, and for other reasons, we'd prefer her to be using a native client instead of the web client, because then we don't have to be entirely depending on TLS for the overall security. So we would like to encourage her to get this working in 1Password on different clients. So the next video, we're going to see her set this up in 1Password for Mac. So she's going to go to Preferences. She's going to select to add a new team. She's first going to do it the hard way. She's going to give up on doing it the hard way. She's going to do it the easy way. And then we'll see that she has the vaults from her team. So she's joining a team using 1Password for Mac. She can enter it manually, which means the account key, the email address, the URL, and the master password. That's not anything that any human or canine should ever have to type. So we've got this scanning a QR code. Here's a handy copy from her emergency kit. And boom, everything is there except the master password, which she types in. And now this instance of 1Password for Mac on this machine has that team data, and we see within 1Password her secure note about strategy. So now this is stored. Again, it's unencrypted, but it's stored by the account key is now stored by the client. OK, we do need to add more people to this, more dogs to this family. We're going to add Morgan. And that is going to look like this. So first, Chaina's going to log in. Because we're switching back and forth between Chaina and Morgan, you get one of the dogs showing who's actually the one doing stuff now. Also, Chaina uses Chrome, Morgan uses Safari. So Chaina sends an invite. And she gets a list of family members, including those pending invites. And Morgan gets email. Rabbit Hunters is using 1Password. Chaina the Psycho Dog wants you to join Rabbit Hunters. She clicked the link. She's now given this sign-up stuff, introduced to the two keys. I didn't see her select that account key, even though she pressed, I've got it safe. OK, and she types in, she creates a master password, and I'll write which was a wonderful master password of ABC123ABC. Oh, look, save your emergency kit. Remind me later. OK, now there's a little bit of back and forth because because Morgan's keys are generated by Morgan's client when she first signs up, for the public key to get to the team administrator, anyway, Chaina has to go through this step. For the user, it's just confirming. What it actually is doing is it is encrypting the vault key for the shared key with Chaina's public key. Anyway, now Morgan can enter in some very precious data that must never, ever be lost. And as you see, she can actually get what's in the shared vault as well, because the key to that vault has been encrypted with her public key. And there we go. OK, so now, we were really, really scared when we thought of this notion of account key. We just thought it's way too easy for people to get themselves locked out. But we, Agile Bits, do not want to have the power or responsibility of doing actual recovery for people who have lost their account keys or forgotten their master passwords. We shouldn't have the power, and we shouldn't have to be sitting there trying to decide whether some request is genuine from the real owner. So what we've done instead is we have given the family organizers or team owners that power. So every time a vault is created by any user within a team or within a family, the keys to that particular vault get encrypted with the public keys of the organizer. But the organizer may not actually have access to the actual encrypted data. That's done through normal kind of access control sorts of stuff from our server. So they don't have access to the data, but they do have the keys for it. So Chaina actually has the keys to Morgan's personal vault, but Chaina does not have the authority to get the encrypted data that is Chaina's personal vault. OK, so here we go with recovery. Morgan, having trashed her Safari installation, has lost her account key and thus lost her access to the secret plans. In an act of desperation, she sends an out-of-band message to Chaina via Droid. Fortunately for our heroes, the organizer of the team has access to all the vault keys, blah, 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 blah. OK, so now, Chaina's gotten this out-of-band message, which obviously I'm not showing. She goes into the admin console, and she sees Morgan here. And she clicks on a begin recovery button. And that really just sets Morgan's account into a particular state and sends email to Morgan about the road to recovery. And effectively, Morgan is creating a new account, but it's with her old email address and identifying information. She gets a new account key. And look, she saved it this time. And she chooses a master password. And so now a new public key pair has been generated and created for her, but you still can't get in until the team owner confirms her recovery or completes the recovery. And this is because it's the completing the recovery in which the new owner sends the appropriate vault keys or encrypts the appropriate vault keys with Morgan's new public key. And so now back in, she gets some tips to not have to go through this again. Save your emergency kit. Write down your master password. Join things in new clients. Now, so one of these things with these emergency kits and these account keys is it's actually the user's responsibility to get the account key from client to client. Okay, but I'm.
Does that have to be done out of band?
It's not handled by us. It's what the QR code is for. So they can either manually type it in. And so here you'll see her setting it up in within 1Password on an iPhone, add account, scan QR code, and here, when you're actually logged in on the web, the Get the Apps link includes the QR code. It really scans fast. I did not speed that one up. Everything but the master password is filled in. Here she types in her brilliant master password. And the server is unreachable because all this demo construction was done on b5local.com instead of actually our real server. So it was just localhost on that thing. OK, and now it's time for a nap. And now, oh, right, I tried to show the QR code scanning a little slower. OK, I'm not really an expert on iMovie. In case you didn't notice. OK, so the questions that we have is, will our users understand that the account key is a secret? They're not going to be reading everything on those pages. Will they understand that it is their secret? So remember, when you're given a license code, for example, when you're given a license code, that's actually a secret that matters to the software vendor. It doesn't hurt you if that secret, if a license code you're given by the vendor leaks. But this is a secret that they need to protect for their interests. And is there more that we can do to prevent the risk of catastrophic data loss? Now, we haven't actually counted, but so far, we're actually doing pretty well from what we get into customer support. The people who are losing account keys are people who are just testing things out of the free system who don't actually have, who actually haven't put data into the system. So the overwhelming majority of I'm locked out, help me, and we have to say tough, have been harmless so far. We also find that almost all of them are from people who've only used the web client. So we really are, I mean, there are other reasons as well, but we're really trying to push people to use the native apps. But we see this new kind of secret that we're asking people to deal with as quite possibly as at least one of the most difficult problems or challenges that we face as we've rolled out this 1Password service as opposed to just the local apps. And you know, we like to think that we try to make it easier for people to behave securely. You know, and so usable security is central to what we do throughout, but we face tough questions with this. So, and that's where I'm going to leave it.
Jeff is an expert at asking questions at Paswords16. So now I'm hoping there are people in the audience who have questions for Jeff.
Jeff, here. Would it work if you have a company with 20 or 100,000 people and that many accounts? Would this work with them, or do you have any experience? Do you know how that would
20,
go?
I mean, it certainly works with 20. It works with hundreds.
Are you interested in a new customer with 100,000 users? That's the question. It's a pretty big license.
Yeah, no. Yes, it'll work just fine.
He's improving, Jesse. He really is improving.
I'm not one of the sales people, you know? I mean, the line, of course, is we're all in sales.
The line is, it scales well with proper policy.
Okay.
User focus.
Okay, so I don't know what the largest company we have is, but thousands we know works. And it should scale very nicely. So it's built to do that.
Hey, I was going to ask, have you had any feedback from users who are surprised that they're under this hierarchy? So you have a hierarchy of a team owner, and then these users who can effectively be overridden by whoever's above them.
Yeah, we haven't actually, so we haven't actually had reports from users, from sort of individual non-team owners and managers saying, wait, I didn't know that my team owner had all this power. But just because we haven't had that yet doesn't mean it isn't something that we're worrying about. I don't know if I got the negatives in there. This is a question that bothers us. So is it clear to Morgan that Chaina has these powers? Now, cryptographically, Chaina, the team owner, has everything. But we also have access control mechanisms so that Chaina is not actually seeing the data, is not getting the data to decrypt from Morgan's vault. Obviously, we'd prefer to have all of these assurances done completely cryptographically instead of having to rely on authentication and access control, but we do have that. But in principle, it would be possible for Chaina to, let's say, get the cached data off of Morgan's computer. Chaina would have to be digging into, because of course the keys that Chaina has access to aren't actually exposed to her in the UI. She'd have to do some digging to get them. Her client has them. That is a line of attack, but there is some confusion. One of the problems, if I may go on a little bit more about this, one of the problems we face is when somebody leaves a company, is their personal vault theirs, or is it the company's? And each organization has a different view. And so we are actually working on trying to, we're working on trying to have a way so that if an organization says the stuff in the personal vault is the person's personal thing, that data can be transferred to a personal account for somebody who is leaving a team. But this is a work in progress. But yes, these are difficult issues. Our view was to try to leave it up to the organizations, but we really can't. We have to enable the organizations to do what makes sense for them.
Yeah, I have a question. I want to make sure I understand how you're generating the KEK. Are you actually using the account key plus the master key in like a secret sharing scheme or something to get that? Or are you rather using the account key initially to authenticate and like pinning that somehow?
Okay, secret sharing would be really cool, and that was the original goal. But mostly it's just, we both are used in deriving it. It's not actually secret sharing. It's the details of the KDF are in the white paper. It's a little bit messy because we left a hole for where we wanted secret sharing to go in. So after you do some key derivation stuff on both, they actually get XOR'd, and then some stuff after that. So yes, it really is two-secret key derivation, not one key for one thing and another key for the other. Okay, whoever has the microphone should talk.
Is there a way to have more than one team owner, or can everyone in a team be an owner?
Yes, and this is something that we encourage, is specifically this, is if you have more than one team owner, you've got more than one person who's capable of doing recoveries. If, let's say, a team owner gets, hit by a bus or loses their account key or forgets their master password. So it's actually, for teams, it's another one of these quests. We try to say, set up another owner organizer. In our original beta, we actually had a more complicated set of roles. So we had what was called the recovery group, but we just merged that with owner and organizer because it was confusing people. But underlyingly, we actually have the ability to specify a recovery group, which is a group of individuals who are the ones who are getting these vault keys and have the power to initiate recovery. So there's more granularity under the hood than is actually exposed to the users.
So when you sign a new team member, is that all done on the, excuse me, is that all done on the client computer of the team owner?
So the invitation for a new team member is constructed by the client of the team owner. The email notification goes through us, but the invitation URL is constructed by the client. And I suspect I'm not actually answering your actual question.
No, so basically you said that you encrypt the master key with the new team members publicly, right? So where do you do that? Do you do that on your servers? Do you do that on the client of the owner?
Oh, sorry. So once you confirm somebody who's joined in, right. So once so when an owner confirms somebody who joins in, what they are doing on their client is encrypting, let's say, the shared vault key to the public key of the new member.
And follow up to that, the reason I kind of led into it is, have you considered open sourcing at least that part of the code to be audited to make sure that's what's really happening?
Repeat the question.
Oh, okay. So then the follow-up is have we considered open sourcing that code so that people can actually see that this really is happening client side? Considered it, yes. We haven't done it yet. I'm sure we've got all these normal end user license things that say, oh, reverse engineering is bad. Just, reverse engineer it. Check it out.
Okay. So Jeff, of course, is going to be around here, and there's also Jesse. If you anybody, and well, everybody should say hi to Jesse. That's my opinion. So once again, thank you, Jeff. And now we're going to take a break again until 5. And at 5, we will have Kirk Hayes from Rapid7 to come here to do a talk and to release a new tool for all of those of you who like to crack passwords. And so I expect to see absolutely everyone back again at 5 o'clock. Enjoy.
Hey. So I was going to talk about my BFF today. Unfortunately, my BFF wasn't able to be here. If anybody wants to come up, I'll talk about you for the next half hour. How about that? No? No? No. My BFF is a tool I wrote, and it's kind of sad, but over the last 6 months or so, I've probably spent more time with this tool than I have with my actual BFF. But I guess that's just the information security industry, right? So, like they announced, I'm Kirk. I'm a husband. I'm a father. I have 2 great kids at home, a beautiful wife at home. I'm also a geek, of course, probably like everybody else in here. I'm a security consultant for Rapid7 doing penetration testing. I've created a few different open source tools. Backhack might be one of the more popular, if you will. It's a Android application file system analysis tool for non-rooted devices, so you can actually access the file system, and it's great for showing risk to customers, but it's also great for giving your wife unlimited lives in Candy Crush. Actually, the reason I wrote it. She stopped playing pretty quickly after that. She said it got boring. I've been in IT for about 13 years, the last 4 in penetration testing specifically. I also blog on the community site for Rapid7, so you can check that out if you want. So today, we're going to talk about different authentication methods. I'll start off there. This is kind of the more basic stuff. You'll see the kittens and at least 1 dog in there. I didn't want to offend either side. I don't want to choose a side on the kitten versus puppy debate, although I am a dog person more. We'll then go into techniques for attacking authentication, specifically passwords. That's why we're here. We're going to talk about web application login forms. My BFF is a tool for attacking login against web applications currently. It will be expanded to other protocols as well. We'll talk about kind of tools that are out there for web application testing and guessing their strengths and weaknesses, and then I'll talk about my BFF. We'll get into deep into that, how that works, the different modules, what you can do to add into it if you want. I'll do a quick demo on its functionality, and then we'll talk about mitigations for these kinds of attacks, since we really want to be able to protect against those. So different authentication techniques. First one up, biometric. It's something that you have fingerprints, retinal scans, voice recognition, facial recognition. Biometrics kind of, about 10 years ago, I was working for a company. We wanted to implement biometrics. It was just, technology wasn't as good then. It was also very cost prohibitive. But something changed in the last 2 years or so. Anybody know what that is? It's kind of bringing biometrics to mainstream. That's right, iPhone. Android phones, if you have one within the last 2 years, most likely has a fingerprint reader. Mine doesn't, it's old. But biometrics is great. It makes it very easy to log in, and we're seeing more than just logging into your phone with biometrics now. A lot of bank apps and stuff are starting to implement those biometrics, which is great. This cat is actually using biometrics to log into its computer right here. If you didn't know, cats have a unique forehead print. It's kind of like a zebra, and they can authenticate that way. That was totally made up. Just kidding around. The other thing we have is a PIN, personal identification number. It's usually 4 digits, could be longer. We use it to log into phones. You use it to log in when you want to get money from the ATM. You have to use your PIN. Don't do that here. I wouldn't trust any ATMs, not with all of you people around. But PIN numbers are great. Log into your phone with it. You could also use PINs as a second factor if you think about it, right? Your RSA tokens, your Google Authenticator, essentially that's a PIN. It's a unique ID that you have. And that's what I think PINs are best used for as a second factor, not a primary. If it's 4 numbers, you only have about 10,000. possibilities, and it's pretty easy to brute force and figure out. And lastly, we have usernames and passwords. By far the most common. You use it to log into everything. Computer, your bank account, different web applications, different protocols. We use it everywhere. And so usernames are easy to get, right? How do we get usernames? Anybody?
We just asked the users.
We just ask the users. We could scrape LinkedIn for the data. I find more and more on tests that companies are putting their entire directory structure, all the employees on their websites. Not sure why, but they think it's not a risk, and that's fine if that's what their decision was, but it makes my job very easy. And in the worst case scenario, when it's hard to find, we just use census data. We run against some kind of timing attack, against some kind of service, and gain a bunch of usernames. Passwords become a little harder. Realistically, people are pretty predictable with their passwords, right? So those are usually pretty easy to guess. But we have a couple different ways to figure out what those passwords are once we have usernames. First is brute force. Like this kitten, it used brute force to get through this wall, just kept pounding in one spot until it got through. Brute force is as many passwords as we can throw at an account until we get in. Simple. Password spraying, here's the puppy. Password spraying is kind of the inverse of brute forcing, right? Instead of brute forcing a password against the user, we're brute forcing users against a password. I'm going to try thousands of usernames against one password, and likely I'm going to get in. And that's going to do one major thing, which is prevent account lockout. And to understand the account lockout, we'll look at online versus offline. Online, any service that's authenticating and checking with the database, real time, they usually have a account lockout policy. And so we want to use password spraying. We don't want to lock out accounts. That's going to cause a denial of service, and we're not going to get in. We want to get in, right? So if we're an online service, such as a web application, we're going to use password spraying on that. Whereas offline, there's no risk of account lockout. But we need something for offline guessing. Anybody know what that is? Hashes. Right, so how do we get hashes? There's numerous ways. But once we get that hash, we can use brute force, whether it's dictionary attack or pure brute force, trying every single combination possible. And there's some tools that we have to try those things. Like I said, we're going to focus on web applications, and so that's online. So we'll focus on password spraying for the most part. Web application login forms are very straightforward and simple. They all are common. They all have three common components. You have your username, your password, and a submit button. It's essentially all there is. The username field, the password field, they can change names. They can be completely unique, whatever they want. But this is essentially what a web app login form looks like. This is one I created in probably 30 seconds. So. The submit button is going to take whatever is the username and password as a payload and submit it to the form, to the page it's going to. And that'll do a check on the database and return a valid or invalid response. So we have different tools to check on this. First up is Burp Suite. I highly recommend Burp Suite. If you don't have it, go get it. But it's very manual. That's the only problem with Burp Suite. I need to review the traffic. I need to figure out what the username field is, what the password field is. And then once I run intruder, now I need to go back and look at what's an invalid versus a valid response. That's okay for one-offs, but if you're doing that test after test after test on this different or the same web apps, it's a little bit of a pain. So there are scripts written in different languages, but these scripts are specific to one kind of application, right? There may be a Citrix portal that you're trying to get into, and you can run a script, and it'll tell you if it's valid or invalid. But if that Citrix portal changes, which there's multiple different versions, and every couple of years, Citrix seems to change all their code. Well, now I need a new script, and that could be a pain. So I created my BFF. What is my BFF? It's a brute force framework. It's modular, so we can just easily add new modules for different web applications or even different protocols. It's intelligent. What I mean by that is I don't want to have to pick out and choose what the username field is, what the password field is, what the valid response is. I don't want to have to put all that in. I just want it to figure out what kind of application is, pointing at a URL, find out what application is, call the right module, and just give me the information. And it goes beyond just brute forcing, and that's kind of the secret sauce on this. And I'll get into that more in a little bit. Currently, I have about 5 modules. There's some of them up there. So for each module, first we're going to fingerprint. We're going to find out what kind of application this is. This could be many different ways. It could be a URL. It could be a string within the body of the response from that page. It could be a cookie value. Anything that separates that application or that protocol apart from others. We'll fingerprint off, and then we'll call a module. And in the module, first thing is the payload. Like I said, that username and password can be different. It could be username, it could be user underscore name, it could be J underscore username, it could be user dot name, it could be user, it could be something totally different. So we create that payload, and then once we do that, we're going to do a connect test. And this is where scripts at this point stop. We're going to tell you if it's valid or invalid, and that's great, but I want more. And so lastly, we're going to do something cool with that. To explain that, about 6 months ago when I was starting to create this tool, I was on an external engagement for a customer and doing my testing, and enumerated about 3,000 or 4,000 usernames off a flaw they had on one of their apps. And then I needed to do password guessing, right? So I ran through with my favorite password, season and year, right? So at the time it was spring 2016. How many use that password? Yeah, all right. Hopefully not, but it's a very, very, very common password that we see everywhere. So I have about 15 valid accounts at this point after using that. And they have a Citrix portal. I love Citrix because I can escape it pretty easily. And once I escape the Citrix sandbox, now I have internal access and get to destroy the internal network. So I tried with the first account, and the response from the page was there's no applications assigned to this user. So, all right, try another one. Try the second one. No valid applications assigned to this user. Third one, what do you think that was? No valid. Okay, 4th, 5th, 6th. I got to the 7th or 8th, and I said, this is ridiculous. There's got to be a better way to do this. So I ended up scripting out the whole thing, ran through all 15, and every single one didn't have any applications. So at this point, I'm like, this kind of sucks. But now I have a script. Run that script, and using my second favorite password, company name 1234, and ended up getting 3 or 4 with that. And one of them actually had applications. So get in, escape the Citrix environment, get internal access, end up owning the entire domain. They had multiple domains and took all that over. So it was very successful on my part. And that's what I mean by going beyond. So each module is going to do something different, and that's going to depend on the module, on the web application, or on the protocol. For the Outlook Web Access and OWA and Office 365, we're going to parse the email. We're going to look for sensitive information. We're going to print that out for you. And we're also going to pull out all the contacts and save that off. For the Citrix, we list those apps out. So now I can tell if it's a Internet Explorer browser, a third-party application, or a full Windows desktop. And I can decide which one I want to attack. For Juniper, we do something cool before the authentication. Often Juniper has multi-factor enabled, but we can usually bypass that depending on how it's set up. So we'll attempt that bypass. We'll see if that works, and if it does, then we'll do our brute forcing against that. And so each module is like that, something different. So we'll go into a quick demo, just a little bit of that. And it might be, if it's a little small, I can zoom in on it for you. But to start off, we're going to just run Python myBFF. We're going to pass it the host. Now, the host has to include the protocol that you're going to use, in this case, HTTPS, and the IP or the host name that you're going to attack. The capital U is for a user list, and so this list has a few users. And the P, lowercase p, is for a single password. Again, one of my favorite passwords to try. This particular app actually failed. It's a small business server, and so if you don't know, small business servers, when you go to the initial web page, it redirects you to a virtual host, which is remote web workplace, where you can remote control all the systems inside. For this, I want to attack OWA, which is /OWA. So we're going to rerun this, clear this out. We'll rerun this using a vhost option. The vhost option is going to, we're going to add in the OWA so we can specify that specific host. And after we run this, we'll see that it finds that it's an Office 365 or OWA server. And then it tries password guessing. We'll find that user 3 was successful with Spring 2016. We then search for sensitive emails, looking for keywords such as password in there. We find that there's some password helps emails from the domain admin. And it's kind of sad that the domain admin actually has the same password. So good job there. And you'll notice at the bottom, we take any contacts and we add it to a file under temp, and then contacts, dash, and then the username. And that splits that out. So now we can use this information to do other attacks, such as phishing attacks, or just trying to email through that, or more password guessing, things like that. Now the second module, last year I found a 0-day in a HP SiteScope application. SiteScope is a application that allows you to monitor your system, servers, network from this web console. And so they had a exploit in that, and so this is the module for that. So we run myBFF again. This time the host is actually, the service is running on port 8080. So once we put in the URL, we add the port. And it's not a separate option, it's all within that host. The module is going to call a Metasploit module that will then exploit and get us a shell through this DNS tool lookup, where we have command execution. And in this case, we're going to use a lowercase u. We're going to try one user and one password, admin and password. And we'll run this. And we'll see it's successful. It's going to call that Metasploit module. It's going to run through. Once it loads up, we'll get our interpreter shell. And we'll run getUID to see who it's running as, and we see it's NT Authority system, which is great. Now we have access to go beyond with that. So the myBFF is going to be available today, right after this presentation. It'll be located on the Moose Dojo GitHub page, so go check that out. I'll be adding more modules as I go. Currently, I have plans for WordPress, Cisco VPNs, and a couple other web apps, as well as SMB, FTP, Telnet, SSH, and other protocols as well. So a lot of cool things coming. And each one of them is going to do something different, right? Well, that's the whole point of this, is I don't want just to know if this is, if the username and password's correct. I want to be able to have it do something with it. And who knows what else. And so if you have ideas, let me know. I'd love to talk to you about that. And so we have password attacks. How do we protect against that, right? What good is knowing that you can get attacked on your passwords if you can't do anything about it? The first thing is we want to detect. Detection is key. Organizations that can't detect these kinds of attacks or attacks against them are going to fail. And so if you can put in place brute force detection, and whether that's password spraying or brute forcing against accounts, if it's a Windows domain, it's easy, it's all built in. You can just enable those kind of thresholds in that monitoring. So it's all right there. Second is multi-factor authentication. As long as you're implementing it correctly, and there's not a bypass like the Juniper often has, this drastically reduces my ability to attack your system. I need that second factor now. So now I need to social engineer an employee, or I need to some other way gain access to that second factor. And then lastly, strong passphrases are key. If your password's long, complex, I'm not going to be able to guess it easily, and I'm not wanting to brute force to lock out your account, so it's going to make things much harder for me. So that's everything. This is my contact information, both my personal GitHub as well as the Moose Dojo, where my BFF is. If there's questions, I'd love to take them. If not, we can talk later. I'd love to meet you guys.
How many Metasploit modules do you have integrated with this? Oh, sorry. How many Metasploit modules do you have integrated with this? Is it just the one, or?
Yeah, so for Metasploit modules, it's just the one. It's the HP site scope that I've written. It'd be easy to add as modules go, but yeah, that's the only one we have currently.
Do you have like an optional switch to specify like an RC file?
I don't. Currently, it writes out the RC file and then calls that RC file to run everything. Those are things that might be worth looking into and adding though. So.
Okay, so we're going to move on to the next speaker, so I have to cut it off there. Just want to remind people also about one of the minor rules of PaswordsCon. We are doing this for good, so any tools and any techniques being released and mentioned here at the conference, use them for good. If you use them for evil, I will tell you two things. Number one, I do not believe in violence. Number two, I really know a cool party trick, and that is I can delete your social security number, okay? So thank you, Kirk. Really interesting, and the tool is available online. And we will have our next speaker on stage in that looks like Evan, maybe, in 2 minutes. eat by their own expense and discuss passwords. Or anything, UX, authentication, PIN codes, password resets, Chinese passwords, stuff like that. If anybody wants to discuss cars, football, women, or anything else, go somewhere else, please. Not interested. And by that, I'm going to introduce Evan Johnson. He's been working at LastPass before. Now he's at Cloudflare. And again, another talk I'm looking forward to, a little bit about password managers. Evan?
Thank you.
Hello. Cool. Okay, so my talk is called Evaluating a Password Manager, but it should say lots of password managers and how people should evaluate them. It's kind of supposed to be give people a holistic view on password managers. So about me, I work at Cloudflare as a security systems engineer. So I wear a lot of different random hats there. I'm kind of the company's de facto AppSec person. Besides that, I hunt vulnerabilities in our products and our infrastructure and everything. And then I kind of either fix them or come up with plans to fix them or push them off on someone else who can fix them. And I've kind of been working on the website too as well. Since we were just talking about accounts and account management, I rewrote all of the account management stuff for the Cloudflare website and how it does sessions, how it does all these different cryptographic tokens like CSRF tokens and stuff. And I also wrote PassGo, which is a password manager written in Go, and it's command line based. The whole reason I wrote it was because I wanted a password manager with more modern crypto for some systems things I do. Like I use it for protecting my SSH keys and whatnot. Oh, and I previously worked at LastPass as an engineer. I worked there for a year and wrote a lot of code. So if you use LastPass and you like it, I helped with that. Okay, so trigger warning, we're going to talk about password managers. And the reason I put this slide is because password managers online are super polarizing. If you've ever read a Hacker News or Reddit thread or Twitter thread about people talking about password managers, it generally goes nowhere. And it's just kind of a lot of people arguing. And basically everybody in those threads is an expert, and they should be the ones speaking.
You're on the right place now.
So a lot of people love LastPass. They loved KeePass. They loved 1Password. They hated all those same things. Different people hate LastPass. Different people hate KeePass, KeePassX. And that's not what this talk is about. This talk is supposed to be really general and something that's unbiased, and you can kind of step back from what you like and what you don't like and kind of be able to evaluate what is good. And so I'm not going to be throwing bad password managers under the bus yet, and we'll talk about that. Okay, so about the talk, we're going to I have a couple goals. So I want to define the properties that all password managers that regular people should have. This talk is mostly geared towards regular people. Point out some things that are really good that password managers, that some of them do, and talk about some technical details about some of them as well. We'll dive into a little technical stuff. And so which password managers? So if you're unfamiliar, which maybe you are or you're not if you're in this room, 1Password is like, I would describe it as the Apple juggernaut of password managers. It was for a long time considered really Apple-centric, and but great password manager. LastPass, Windows and Linux people liked it. These two are probably the oldest, the two at the top, LastPass and 1Password. And LastPass is also got really popular. The Android UX was really great for, they really did well on Android and Linux and Windows and kind of not Apple for a while. And then there's Dashlane. Dashlane is pretty pricey, and they've raised a ton of venture capital. I think I just checked before this talk, and it was like 52 million. They've raised a Series C, which is an absurd amount of money for password managers. Keeper, which is from, I first heard of it at LastPass, and it kind of got its start on mobile, I think, and it kind of developed from there, and they took off from mobile. Then there's KeePass, KeePassX. These are, the whole KeePass environment, like ecosystem really confuses me, and I don't fully understand it. There's lots of them. And then PasswordBox, rest in peace. They got end of life. They got bought by Intel a couple years ago, and they just got end of life. Pass is a command line password manager written by this really good systems programmer guy. It's written in Bash. It's Git backed and GPG based. And then, so I put these two at the bottom. These are the most interesting. Excel spreadsheets and password journals. These are things people might be using that we want to compare all of these together. So this is kind of a generic design diagram of it might be hard to see, high-level parts of a password manager. So I put 4 of them, and there might not be 4 of them, and maybe some of them are more tightly coupled than others. You have the cloud servers where if the password manager syncs, you have servers that the password managers or the passwords are stored on. Then you have kind of the back-end core of a password manager. So if you use 1Password, there's a thick client there, and LastPass, it's all extension-based. And this is the part that talks to these servers and gets down the passwords and decrypts them. And then you have the application core integration. This is the UI, all the features that are built on top of this decryption, all the junk that gets decrypted, all the features that you see. And then, I don't know why I put this last one. It's not really a part of the password manager. Just the application that the password goes into. That's a final resting place for the password. Goes into, hopefully, the correct application. And like I said, some password managers might have all 4 of these. Some might not. So the first part is the servers. And this is going to be missing from things that don't sync. And the important thing here when you're evaluating a password manager, the first is really obvious, that your passwords should not be on the server in plain text. And there are actually some like enterprise password management solutions where it is in plain text. And it's not just enterprise. These are like really big business, like 100 million in revenue, doing password management that I've heard of, and it's kind of insane. But what else should be encrypted here? It's everybody kind of does it different. All the password managers. So the big 2 things that generally differ is some password managers don't encrypt URLs, and some other ones don't encrypt usernames. And I don't think there's a right answer here about whether or not that's good or bad, or I think there's room for improvement for both of them, but I don't really see a huge reason why having everything encrypted, or I'm not sure how to weigh this. And so I came up with 2 tick boxes for evaluating what's stored, and it's whether it's encrypted, which pretty much all password managers encrypt what they have on their server, and then the passwords that are on the server, and then whether or not they encrypt all site data. So if a URL isn't encrypted, then they wouldn't get that second tick box here. The password manager wouldn't. So else is on this slide? All right, and you generally have a back-end part of an application that does all this heavy lifting of fetching encrypted blob data and decrypting it. And this is pretty boring. All it does is kind of consume an API, get a bunch of data, prompt you for your password, and decrypt it. Sometimes, so this is where most of the crypto lives. So all the crypto primitive choices live here. And I guess that's significant because all the crypto lives there. And all the features that users see, autofills passwords, contains all the bells and whistles, contains user interface. So this might manifest itself in different ways. Like autofill, most password managers will have an autofill feature where you just press a button and it pastes your password in, or maybe not paste, maybe it'll just modify the DOM on an HTML page. And that all lives here. And all the flows of generating a new password and saving it and then communicating with this back-end process that then talks to the API to save this new encrypted blob. That all starts at this layer, user-facing. And then one of the most important features that you'd see from that users see is security details about their passwords. So if they're reusing a lot of passwords, if their weak passwords are everywhere in their password vault. Good password managers will tell users that they have bad password hygiene, and they might be really loud about it. Okay, so what actually matters? And I think this breaks down into two things. What features should all password managers have, and what are security critical and need actual technical eyes to look at and kind of evaluate. And I think the first one is more about usability, and the second one is security, because that's kind of all there is in this world. Okay, so what should they have? High level, really fast. The most important features that I came up with is password manager or password generator to create different kinds of passwords. If a password manager doesn't have that, it's pretty bad. Just duplicate password finder, finding security details like we mentioned. If you have duplicate passwords, if you have weak passwords, your password manager should notify you. Strong crypto. This is an interesting one, which we'll talk about in a minute. But your password manager should have strong crypto. Just having crypto doesn't really help. It has to be strong, and not all password managers are vetted as such. And I think you won't have as big of a problem with the big names that I listed at the beginning, but there are hundreds of password managers, and once you get out in the weeds and you may find something that works for you, it's kind of scary if nobody's actually looked at the technical details under the hood. And then import export, you should be able to jump ship if you hate your password manager. And the most important one that I think in 2016 is a password manager having good mobile user experience. And what did I put on this slide? Password managers with a mobile. Yeah, so in 2016, like, so many users are mobile first, and that is getting more and more prevalent. And if you just download KeePass XYZ and it's somebody just forked KeePass and made some changes, and you can't actually use it on your phone, even if it's really cool and open source, it is not going to help you that much. And so so here is like a Snapchat sign-up screen, and I picked Snapchat because I kind of picture Snapchat as kind of the next, well, it's already arrived, the next social network. And I also picked it because at the beginning of Twitter, people were like, this is really stupid, and it kind of became something really big. And so people signing up on Twitter, they might choose a stupid password. Like that, my first password on Snapchat was really horrific, I'll tell you. But like, who knows, Snapchat might be really important like a year from now. People might be getting their news from news clips on Snapchat, who knows? And so if a password manager can't reach their mobile users, that's really bad. Also, just outside of password managers, authentication on mobile devices is just atrocious. People have tried like federated credentials in apps, like Pokemon Go came out and they had the Google sign up, and besides the fact that like you could sign up with your pre-existing Google account, and besides the fact that the permissions were way too permissive on what you actually allowed Pokemon Go to do, it was just bad UX. Like, you had to completely re-enter your username and password. You didn't get anything for free. So password managers are the best we have in mobile UX right now. So this kind of shows off on Uber, who uses the Agile Bits. The 1Password, they have a way for apps to integrate with a password manager. And I feel strongly that this is, if your password manager does not have this option, if you use iOS. So obviously it's different for Android, but on iOS, if you're not taking your password manager seriously and you are working at a password manager company, like, this is super important. This little, it's in the red, not my email blurred out, but the little lock icon, that will allow you to just click that and paste your password into the password field, or it's not paste. I'm not sure about the details, but it allows you to get this icon and utilize a password manager from inside of an app. And the other thing in mobile is browser support. And while most apps have not figured this out, most password managers have figured browser support out, and pretty much all of them will support different. Pretty much all password managers support this way to be presented in a Safari browser, which is good. And so the important reason why I mention mobile and really focus on mobile is I think it's the way to win an argument on the internet, since that's the only place good important arguments are fought, with people who use Excel spreadsheets and password journals and stuff. I got in an argument with somebody on a Slack channel, and this guy said all of his passwords were too sensitive for a password manager, and he could never trust software. And he kept an Excel spreadsheet, or he kept something that he refused to tell me because it was too high security. And I was like, first of all, this is just absurd. But second, like, the mobile case just, I feel like, completely trounces his argument because who knows where this guy will be. He might not be at home when he signs up for Uber or for Snapchat. And if he doesn't choose a good password, that's like bad password hygiene, and his system fails. The scary part of password managers is go to the Apple App Store and type in password manager, and there are like hundreds of results, and who knows what these things are doing. Okay, so what features actually need security evaluation? And I think after last week, we all know browser filling logic needs security evaluation. Integration with between the browser extension and whatever background. No, integration between like what the user is doing and how the user interface talks to the back-end system that decrypts all the passwords. Because in Dashlane and 1Password, it's they talk over a WebSocket, and it's not tightly coupled. Like different password managers all have a different software architecture, where some are more monolithic, where it might only be extension based, but some really rely on this thick client on your machine. Crypto primitives. So this is all came from browser world, and crypto primitives don't exist that well in JavaScript. So basically everybody just copies and pastes in their crypto primitives that they need. And who knows who's looked at these? I have no idea. And then HTTP headers, random regular AppSec kind of things. So how to dive in and look under the hood. So the parts you're going to be looking at is the API, the crypto, the browser extension. And if you are an AppSec person and you've always wanted to learn about how to dive in, we're about to look at it quickly. So here is an example of how you could examine the API for LastPass and how it works. So for LastPass, PasswordBox, most of the monolithic extensions where they don't have this client on the machine, LastPass does now, but all the logic's still in the extension. You can just go to this extension screen in Chrome, // extensions, and load up the background page and start diving in. You have to click there's a checkbox in the top corner that says enabled. You have to click that, then you can click background.html, and you can start diving into the technical details of how the extension communicates with the API for a lot of extensions, actually. And here is my LastPass vault, and you can see all the. Once you click background.html, it'll pop up a Chrome debugging window, and there's a network tab. You click the network tab, and you can see all the requests that are being made, and you just click on them, and you can see all the technical details. It's amazing. And apps that don't do this, it's a little harder to kind of dive in and reverse engineer, because you have to reverse engineer a thick client instead. Who knows, like maybe they do like public key pinning inside their thick client, and it's a little harder to dive in. This is really nice because Chrome gives you a debugger. It's amazing. Next is examining the crypto, and pretty much all password managers have pretty similar crypto primitives that they've chosen. Most of them have chosen like AES-CBC and similar encryption and PBK-DF2, SHA-1 for deriving a key. And I think this is mostly because of difficulty getting primitives into the JavaScript world where they might need them and whatever. But this, I think that the best practice now is to use an AAD cipher. And it's really hard. One challenge that you kind of realize when you're working as a software engineer on a password manager is, let's say tomorrow you wanted to switch from AES-CBC mode to a different crypto primitive. Let's say you wanted to go way back and way weaker and pick DES, which we don't use anymore, and please don't ever use. And it's really hard because you can't just flip a switch and everybody's passwords are encrypted with something different. Moving forward is not easy. Once you've chosen a primitive, it's really sticky. Why? Who said why? Why is it sticky? Just because, so you encrypt all your passwords. You have 1,000 passwords in your vault, and we chose, let's just pick something really weak, DES, and we want to move to AES. And you would have to download new code from whatever update process the extension has and the client has, and that all your things have to be decrypted and encrypted again, or you can wrap them, and that's kind of weird, where you start encrypting a ciphertext, and it's just kind of not an easy process.
Let me just give an additional answer to that, is that remember that people are synchronizing their data across different clients, and that data synchronization problem, getting this working across all clients, makes changing your data format really, really, really hard.
Yeah, it's not easy, and so now we want authenticated encryption, and pretty much no password managers have authenticated encryption just because of this problem. Like, if it was easy, everybody would do it, but it's not. And so examining the browser extension, thanks, this is Tavis Ormandy. He found a really bad bug in LastPass last week, and he's looking at more password managers, so I put his face up. And so finally, examining the browser extension. So the part that he found the bug in LastPass was their autofill logic. And this is fairly easy to dive into because of Chrome DevTools again. Just right-clicking on a page and clicking Inspect Element, and then you can click, you pop open the developer tools, then you can click Sources, and then Content Scripts, which is right here, and then you can just browse JavaScript, all the JavaScript fill logic. This is 1Password's fill logic, LastPass fill logic right next door. It'll format everything for you. It's really easy to dive in and start reading their code and evaluating it. And so out of this talk, I kind of came up with an idea where, if you've ever heard of the EFF, and a lot of people have created scorecards for things like encrypted messengers and whatnot. I want to come up with a password manager scorecard where there is a lot of properties that I define, and password managers either get a green check or a red check, or red. I don't know what that's called, actually. A red no. I think this would be really useful, just to have something where non-technical users can kind of come see and get a non-biased way to evaluate a password manager that suits their needs. And I got this idea while I was working on this talk, and so I have not made it, but I want to publish it in the next couple weeks and work on this. So maybe you'll see it. I hope you see it. But I plan on publishing it soon. So does anybody have questions? Sure.
So for those of us who work with users all the time, where will you publish it?
So I have no idea. I wanted to work at Cloudflare. Our PR people have good contacts, and I was hoping to get it somewhere that it might get visibility. I plan on putting it on my Twitter on EJCX_ and Hacker News or something. I don't know. Hacker News and my Twitter are places that you might expect to see it.
So do you know of a personal password manager that syncs where you can run your own server?
Yeah, so Pass, which I mentioned at the very beginning, the website for it is passwordstore.org. It is Git backed, and it's, if you like GPG and command line, the reason I recommend Pass is because there's kind of been an ecosystem built around it where you can use iOS app to access your passwords as well, and it uses Git as the back end, and so you can just host a Git server and have your passwords.
Last one.
Jeff Goldberg from Agile Bits, makers of 1Password. At the risk of pushing self-serving criteria, I was a bit surprised at the extent to which you downplayed the not having the URLs encrypted, particularly if that is actually stored or available to the operators of the system. I mean, now for a long time, I mean, I understand the technical reasons why it's difficult to get those encrypted. And when we made the transition to a new data format in which we actually managed to encrypt that, we have been hammered by our users for making that transition too slowly. So
what I'm going to do, I'm going to ask both Evan and Jeff to join me for dinner, and I will put them on the opposite sides of the table.
No. I don't think you need to do
And
that.
anybody who wants to come and watch are more than welcome to do that. But now I will have to say again, thanks, Evan.
Yep, thank you.
And we will move pretty much directly onto our last talk. Okay, so while Mark sets up his laptop, there are also events later this afternoon and evening. You have them in your program. If anybody, as I said, if anybody would like to meet up for some food or drinks or anything, I will go down to the pub 365 at approximately 7:30. If you want to join in, please feel free to come down there and look for us, okay? 7:30 down at the pub 365. Very easy.
Thank you.
See you later.
Yep.
What do you need?
What
kind of output do you have?
He has HDMI.
And you need HDMI to VGA.
Yeah, we do. That's the only thing he has.
I brought one too, but I left it in my room.
Then you would eventually have to run into the speaker ops room and ask them if they have. I mean, I know we have adapters for anything, but they are not necessarily in this room. Hi, Klaus. Nice to see you. Yeah, getting started already, huh?
Yeah.
Hi. Yeah.
So we have to be happy.
Yeah, I mean, seriously, you're working.
I am. Every single day that I don't get hacked.
Didn't get hacked, drink.
Man of many adapters.
Well, this is their stuff, thankfully.
Million one
Just
connectors.
calling for one.
Appreciate all these exciting tips. They're kind of forced into
on there.
Yeah.
Display shows up.
You have to be the networking side, I think.
That one?
I've heard most of my guys came from they all let their own such an awful. They were so happy. Apparently, places where the pressure is solved is generating tickets, just free tickets, just opposed to
Why don't you go to display properties from the desktop and see if that monitor shows up. Yeah, it doesn't.
Detect right there. Oh, you're not have it in all the way.
Oh, there, got it. Hey, there we go. And go there.
All right.
You're all set?
Okay.
Okay.
Start camera.
It's rolling.
Okay.
Okay, so again, this is Mark Burnett, our last speaker for today. He is the author of the very acclaimed book, Perfect Passwords. I was actually considering to bring it here to Las Vegas to have it personally signed. I still have it at home, Mark. Again, Mark came with this talk. Have you actually been tormenting your family over this?
Oh, yeah.
Okay,
Oh,
yeah.
big time.
So I think this is going to be very interesting to listen what he have actually been doing. So, Mark, feel free to get started.
All right. Okay. I'm Mark Burnett. I guess.
Hi, Mark.
I do stuff, and I talk about stuff. So, but on my first slide here, I'm going to read my intro. Okay, so this talk is about passwords and killing passwords and really the mess we've made with the whole passwords thing. Because although we like to think that we have played a part in making the world more secure, mostly what we've done is alienate users. We've made them log into everything over and over and over and over and over. We tell them to make sure the password is really strong, but don't write it down. And of course, don't forget it. Be sure to add some special characters, or sometimes, when it's a bank, don't include special characters. Banks. We've bombarded users with, I gotta change my screen here. We've bombarded users with a never-ending supply of policies, CAPTCHAs, remember me boxes. I'm behind now. And of course, you don't check the remember me box, even though it is everywhere. And of course, users retaliated how they know best with memes. And you know, we can't blame them because we created them. We created those monsters, and they are monsters. But I have got this little analogy here. Actually, I just saw this video and I thought I've got to find a way to work it in. We are all losing. Okay, now I don't know if you notice, it's kind of quick, but I watch around this area. I'm going to zoom in and slow it down, but watch around this area because there was something that just kind of went viral quick there. Yeah, you probably missed it on the first time. So, all right. So we've been doing passwords for several decades now, and you think we've pretty much got it figured out, right? But But let's look at what we've accomplished, and let's kind of do a report card here. Password policies. It seemed like a good idea, but it turns out we really don't know what works. I mean, users have bad passwords, so hey, let's force them to have good passwords, but that kind of end up with not enough requirements, too many requirements, strange requirements, no two identical consecutive characters, and I don't know if you know me on Twitter, I complain about a lot of stuff. Short password explanation, policies for policies. I mean, come on. Failed. User education, they're still confused. As much as we've tried, they still suck at passwords. They still hate passwords. They still want to kill passwords. They're always trying to find some way to work around their passwords. So we're going to fail on that too. Password managers, hey. Now, I know we've talked a lot about password managers, and it's kind of an important thing to a lot of people here, a lot of person here. But we got to face it. They're just a temporary fix. They're really not a long-term solution. They kind of tacking on to this problem we have of passwords, and we're trying to fix passwords by having password manager. But yeah. Hardware tokens. Hey, now, hardware tokens we've been doing for decades now. I mean, we've been trying to get it right, and we've tried a lot of different things, but the thing is, have you ever tried to get someone to use a hardware token who isn't in the security business? Or unless the company forces them to, it just doesn't happen. And then there's that. Now, biometrics, hey, users like those. Fingerprints, eye scanners, voice matching. Movies have been doing it for years. It looks cool. It seems really secure. I mean, if it's something really secure, they're going to voice match, right? But we still haven't figured out how to make it. We really haven't figured out how to make it secure, and we haven't figured out how to make it anonymous, and we haven't figured out how to make it work everywhere. Yeah. Oh, I don't have sound. I just realized. That's cool. Okay. It sounded like that, kind of. Jeez. All right. So the way this started is Intel, this particular topic started, Intel had me write an article a few months ago, and they've seen a lot of my tweets and stuff, and they thought, hey, wouldn't it be cool if we wrote an article about killing passwords, and they thought, let's get a bunch of equipment, let's try it out on my family, and kill passwords, see what really works, and yeah, that didn't go so well. But I got some wearables stuff, some YubiKeys. I had a bunch of those laying around. Eye scanner, fingerprint scanner, and a password manager. I used Intel's TrueKey in this one. I mean, the experiment was really fun for me, but I did it for a few weeks. I got all these things hooked up. I got everyone in my family hooked up. I had this interesting. We have this pretty diverse thing in my family. I got my wife. That's another story. Three of my boys. I got four, and my father-in-law. Oh, especially my father-in-law. I'll just let you guys I don't know if you can see those, but.
You gotta read some of them.
My father-in-law put tape over his webcam, transparent Scotch tape. I'm amazed at, despite my best efforts, my father-in-law's ability to fill his computer with every spyware known to man. My father-in-law today told me he needs to get a copy of Harvard Graphics. Then I realized he was serious. I'm just going to say the world is not secure until my father-in-law can go 90 days without getting some kind of infection on his laptop. No, every hack today wasn't because of the passwords I released. Seriously, people are like my father-in-law. Okay, my SSID used to be not found, my home group blocked, and my Plex server broken. My father complains that nothing works at my house. So, well, I have so many stories. What's that? So anyway, I've got a pretty diverse group to pull from. Needless to say, my father-in-law got the cat book, which is, password manager, cats, hey. Password manager disguised as a book about cats. No, anyway, it's really interesting though, because I got this stuff. I got this, I got one of my sons to use YubiKeys. It's kind of a hack, but I got him to, use them for all his different passwords. Some of them were statically hard-coded passwords, but the whole thing was to kill passwords at that point. My wife, I got her this, this fitness tracker, and the thing is, though, once she found out that it was worth how much it was worth, she wanted to sell on eBay, so that didn't last. And it was just like it lasted about 3 weeks, and then you can see it all ended up back on my keychain again. They just kind of gave up on it. But why can't we get people to use this stuff? I mean, why is it so hard? I mean, I couldn't even get my own family to do it, and I would think I'd like to have some kind of influence over them. I mean, what do we need to do to get user participation here? Wait. Oh, hey, let's just do them all. Okay, so it's got to be usable. I mean, if it's not usable, I mean, obviously it's got to be usable, but it's got to have it's got to be easy to install. It can't have a lot of terminology, crypto terminology. It can't be frustrating to that's the thing with my wife. She gets really frustrated with stuff. So if it doesn't work, like the first 2 times, she's ready to give up on it. So it can't be frustrating. Needs to be flexible. Needs to work across a lot of different platforms. Now there's a lot of cool authentication stuff, but it only works on Windows or it only works on your mobile. So it's got to work on different platforms. It's got to be compatible with a lot of different authentication technologies. I mean, Windows Hello is nice, but there's a lot of stuff you can't use. You can't use a YubiKey to log into Windows Hello. It's got to be invisible to the user, and they just really got to feel like they're not even using it. I mean, that's the biggest problem with passwords. They're far from invisible. They're struggling with them all the time. I mean, just monitor the keyword password on Twitter, and you see all this. It's kind of funny, but you see all kinds of complaints about passwords. And it's got to be ubiquitous. I mean, if your bank sends you one token that only works with their website, I mean, what's the point of that? It's got to be something that you can use on all the different websites or all the different systems, or if it only works on websites but not the OS, or vice versa. I mean, it's got to be something that works across different systems. So with this in mind, I decided to take it to the extreme. Okay, it didn't work with my family, but I thought I'd try it myself. I mean, I'm pretty brave. So I got all this stuff together. I added a few more things to my keychain. I got this, there's the eye tracker, and I installed it all in my system. My system really doesn't boot very well anymore, but I installed it all, and I tried it out. It's like, what are we doing wrong here? I mean, why isn't this so hard to figure out? And just to be clear, we aren't going to be killing passwords anytime soon. You guys know that. I'm just going to skip that one. So let's talk about password managers. I said they were a temporary fix. They're just kind of a crutch to get us through to make passwords usable for now. I mean, it may be 10 years, maybe 20 years, but they're really not going to last. It's not a long-term solution here. I mean, we don't know our own secrets. I mean, we create these we don't even create the secrets. It generates the passwords for us. It manages the secrets for us. It enters them in for us. But it's not. It just kind of breaks the whole security model. It breaks the whole concept of having a secret, because we have this master password, but that's not really the way this is going to work. And we just got to look at that. Look at passwords. They're a transition. They're to get us to this place where we can, we truly have a seamless system where we're doing more than just typing in static passwords. A tool is typing static passwords for us. Sorry. But to get to that place, we're going to have to get operating system support. We're going to have to get browser support. And I know that, where's Mike West? Yeah. He thinks that browser shouldn't be involved, but you got to have the operating system. You got to have the OS. It's got to have a trusted platform to run the browser, and the browser's got to have that trusted authentication platform to log into your websites. And if we don't have the browser involved, if we don't have the operating system involved, we're just not going to get to that. I mean, it's just we have to. The only way we're going to do that is to get every component integrated. And so who's going to do that? No, I'm serious. Who's going to do that? I'm asking for volunteers. No? Okay. So what you have, we've been doing this for a long time. We've tried magnetic stripe cards. We've tried smart cards, token generators, all kinds of technologies. And that's what users want. They want something that's easy, something you just plug in or you just be near your computer, unlocks it. If you lose it, you've got this thing to log in. If you lose it, you grab another thing, and that's your thing. And you use it to log in, and you lose that thing, and you get another thing. So, that seems like a great solution, but hardware is the classic trade-off between security and convenience. And what seems great for users really doesn't work well for security. So, and vice versa. But you missed that. Let me do it again for you. So around 2005, a lot of websites realized they needed to make things more secure. So we started like PayPal and eBay and some banks. They started distributing these Vasco Go tokens. You push the button, it gives you a 6-digit code. And actually, I really like these. I mean, I've had these for 10 years, and the battery still works. I still use them on my PayPal account, but I guess they really kind of sucked for the companies because they just, it got to where PayPal just kind of hid that feature for a while. It must have been a major support headache. So we what's that? Nobody used it besides you and a couple of other security people. Exactly. Nobody used them but me and like you probably, and like some other guy. So Bluetooth. Now, Bluetooth's interesting because people are always trying to. I mean, Bluetooth seems like the perfect way to do this. You don't even have to touch it. Just go near your computer, it unlocks it, but it's not exactly secure. I mean, it's always on. It's easily spoofable. It's visible. I mean, within 30 feet or more. If you have a. I mean, sometimes I've seen people do up to 100 feet with the right antenna. Vulnerable to man-in-the-middle attacks. I think there's going to be a talk at DEF CON about that. But everyone keeps going back to these Bluetooth stuff, and the protocol is insecure. There's just really no fixing that unless we fix the protocol. But one thing you do is you treat it like it's an insecure network, and we know how to deal with insecure networks. I mean, you have proper key exchange, you have certificates, you can have PIN certificates. You don't just detect the presence of the Bluetooth MAC address. You exchange. You do a proper challenge response. You exchange a time-based or digitally signed time-based token, but no one does that. That's a problem. This tracker I use for my wife. I just end up using some software. In fact, there we go. I end up using some software. This Rojos. It's kind of cool. You have all these different things. You've got USB flash drive, Bluetooth key, PKCS number 11 security module, YubiKeys. You can plug in all these things, and you can log in with Windows. Really nice. I did that with my wife. Integrated it with a couple other things, Tasker and some stuff on her phone, and it worked good until, like I said, eBay. My wife. Okay, I'm not going to go on that. You know all the stories about my wife and eBay, yeah.
It's not nailed down. It's going on eBay.
Yeah, that's right. I used to have these DEF CON badges, like from 5 and 6, but those go for a lot of money on eBay, it turns out. These fitness trackers are actually kind of cool because you think about it, they've got, first of all, it's something you have, you got possession there, but you also got GPS on some of them. You've got biometric markers. I mean, this one's got a heart rate sensor. You know, if there's done authentication through heart rate. It's got microphones on it. You could do voice authentication. It's got galvanic sensors. You know, basically you got a lie detector test on here on a watch. But I mean, there's a lot of different possibilities. I mean, you could, if you really wanted to make that work. I mean, wearables are a really interesting thing, and it was, you know, it's pretty transparent. Microsoft tried to do it with their thing. What's it called? What's their wearable called? Band. Yeah, there we go. Band. And you know, but just basically, if you push a button. Gatekeeper. Now this one's kind of interesting. I actually kind of like this one. It's this little thing right here. You got a USB dongle, and then you just put it on your keychain. You walk up your computer, and it's really accurate. Like you can say how far you want it to be from your computer. You can say like 3 feet or 5 feet or 15 feet. And it's really, I mean, you get within 3 feet, and it you know, it locks, and when you walk away, it unlocks, or other way around. You can choose how you want to log in. If you want to log in with just the gatekeeper or with a PIN or whatever. And it's just really cool. I actually kind of had fun with that one. But then I saw this thing. It says, enter your Windows password. Enter your Windows password below. This enables you to log in to your PC. Whenever someone asks for your Windows password, you know that's a bad sign when authentication. So I saw this, and I saw this, and it was just bad. I mean, I don't know if you can see here, there's my PIN, you know, and the encrypted, you know, and there's all the code for encrypting it, and yeah, it was just bad. I mean, it's kind of sad because that was kind of cool. Anyway, we've been working with them, and they're improving that, but it's, you know, there's a lot of potential there. There's some way we can go with that. You know, some Bluetooth device that's pretty seamless for the user. YubiKeys, right? I mean, we all like YubiKeys. How many people here have a YubiKey? All right. How many people have 4 YubiKeys? 1, 2, 3. What's that? On which one? The 4, oh. Well, it depends on how, I mean, what kind of crypto you're talking about. Because there are, I mean, the YubiKey is writable, and you can put in, you can write your own Java modules in there. So I guess it depends on what you're using it for, but you know, it depends on how you're using it. And I think the YubiKey is probably the closest to getting a real hardware token that's usable. It's cheap. U2F standard. I got a few of those U2F tokens. This one here, it just kind of folds out and tapes over, and I got it for $5 on Amazon. Widespread adoption. A lot of people. Well, I should say widespread adoption among us. Really easy to use. You know, put it in, push a button. It's got the YubiKey itself's got the OTP, smart card, channel response, other stuff. But we still can't get people to use them. I mean, I gave my son 3 YubiKeys for all those different, you know, 6 different passwords because, you know, it's about all he had. I still couldn't even get him to use them for that. I have one of my sons, my 10-year-old, he actually still uses his YubiKey. Yeah, you know, logging into. He's the only one of all my family who actually survived the whole thing. He uses his YubiKey to log into Gmail, but we can't get people to use them. I mean, that's about as easy as you can get, right? NFC RFID. Got a ring here. It's got 2 little NFC tags on it. And oh, hey, I got on the back of my I got another NFC tag. Back of my wallet, I got NFC tag, so I can swipe my wallet, and in the bathroom I can swipe and launch my apps I need on my phone. Yeah, some do. Yeah, the Nano, I believe, or yeah. I think, I don't know, one of those. RFID is cool. The RFID thing, you know, I mean, I got these little scanners I put on my computer. Oh, you should have seen my computer was such a mess, you know, all the stuff. I had stuff taped on there because I had so I got NFC and RFID, You know, so it's kind of cool. I actually got another one for my garage, so I can open my garage door with that, and it worked great for that. But I don't, you know, the thing is, you can't change it. It's just a code. I mean, it's spoofable. It's easily copied. You can't turn it off, so it's not like Bluetooth. I mean, at least Bluetooth, you can kind of secure it by only turn it on when you need it. You need a reader. I've got, you know, those readers, but I don't even know what that is. Oh, so I used Event Ghost in Windows. I used that Rojos thing. I used Tasker, and kind of got all this stuff integrated. And it worked out pretty well. I mean, it's really cool, but it's just not secure at all. I mean, it might work for home users, and that'd be, I don't know. Just don't do this. I mean, unless you got some foil gloves or something, because, you know, once someone, I mean, it's spoofable. Someone scans it and you've lost it, and you got to, like, what do you pull it out and put a new one in? I mean, you can't really change it. I mean, that's worse than your fingerprint. Mobile devices, some based on Google Auth. I mean, there's a lot of them. Some are proprietary, some use algorithms, some use custom algorithms, some use push notifications, some use a combination of those things. They're really common, they're easy to use. Everyone's got some kind of mobile device. People are more willing to protect it, and they're going to notice when it's gone. It's not going to be gone for long. The problem is they're vulnerable to remote attacks. So you could have some bad app that someone installs. They're slow to replace. I mean, you can't just go get a new one. On the plus side, there is a lot of support for Google Auth. I mean, I've probably got 30, 40 on my Google Authenticator, and it's just constantly growing. So I'm not even going. You guys get that. So, oh, I forgot about that. Yeah, so that's what I call them. What can be chopped off. I kind of ran out of graphics, so I started using some stock photos. So I guess the thing is with fingerprints. Here's my fingerprint scanner. It's a little tiny one. The problem with fingerprints, and this is the Authentic. They had a problem where they were storing the password encrypted. See what the way that some of these things work is, and the reason why I said that was bad news a bad sign when they ask you for your password. They'll encrypt your password and then have some logic in the program that authenticates you. And if you pass authentication, then they decrypt your password and use that to log into Windows. And so that just means that your password is stored somewhere, and most likely it's got a hard-coded key somewhere, or it's based on your PIN. I mean, it's really cool. It's built into Windows, you know. But the thing is, you can't log into a website with your fingerprint. You don't have, you know, there's not really much you can do with that. You just log into Windows, and that's about it. Or maybe your mobile phone as well. And Iris. Now, irises are interesting. I like this one the best. That camera is just kind of weird, I think. Yeah, this was my personal favorite because it just worked really well. It was just really seamless. It's almost it worked almost as well as the Bluetooth. Yeah. Okay, so let me. Wow, you can't. It says looking for you, making sure it's you, and it logs me in. So it's kind of cool. But man, those pictures, it's kind of freaky. But you know, if we could get something like that to work. I mean, like I said, we get the OS support, we get the browser support, and then we get the application support. But the thing is, we're not going to log into any websites with this. So there's really not much. I should have got a better picture, I guess. But you know, there's really not much you can do with it other than just. I mean, you can play asteroids. It's kind of cool. You look at the asteroid and it blows it up. Some games, but it's not much you can do with it other than that. I mean, it would be nice if we could get that more commonplace, but they aren't really cheap. It's about $180 for this.
there has been a cock-up, so there are catering people waiting outside to take over the room. So I have to ask Mark to speak very
5 minutes?
5 minutes.
Okay, I can do that.
Yeah.
Thank you.
Give us the conclusion, Mark. We know it sucks.
Oh, you give it away.
The interesting question is essentially, is his family still alive? That's my main concern, to be honest.
Face, voice, fix, don't ask for passwords. If you ever do use like any kind of biometric or alternative authentication, ask for your password. There's several of them that did that. It's just that they're storing it somewhere. Oh, and there's this thing. I mean, you've got like LastPass, you can use YubiKey, but if you lost your YubiKey device, click here to disable YubiKey, and then over here it says use email verification instead. So it's just kind of. Why not just email verification in the first place? I mean, you're not any stronger than that weakest link there. So expanding modalities. I'll go back to fix. Fixing it is you start strong, work backwards. You allow a lot of different, allow support for a lot of different types of authentication. A lot of these, like LastPass, for example, it lists these certain two-factor authentication things you can use. If they're not, they're obviously not going to be available on every device or for every person. I mean, not everyone has fingerprints. I mean, it's just you got to have flexibility based on where the user is, what kind of device they're using, where they're logging in from, and other factors that that could make it potentially suspicious. So you kind of take away, is this suspicious? You kind of take the score away, then you add on with the stronger authentication factors to get you back up to where you need to be, to a certain score to pass them. And here's some kind of interesting things that you could look at: where you are, when are you there, where you were, which device you're using, who you know, who's with you. But now here's some you probably don't want to use. Something you forgot, something you lost. Anyway, something you ate, how you bleed. So I thought you guys might want to use that hashtag and kind of carry that on. But rules-based authentication, that's one thing I like to see. I like to see some kind of, within Windows Hello, for example, you can log in with a fingerprint or with your face, or you can log in with a PIN code or a password. But it would be nice to say, I want to log in with 3 of these, 3 out of 4, or I want to say, these times I want to log in with 3 out of 4, or if I want to say if there's been more, certain conditions. It would be nice to have a rules-based setup that you can decide, that we could decide. Let us have 5 different ways to authenticate, and you have to have 3 of them. Artificial intelligence, there's a lot of potential there for understanding when to require multiple factors or 3 or 4 factors for authentication. Identifying devices. Some of the password managers do that already. Smarter wearables, that would be really cool. Okay, okay, and then there's this. That's it. I guess we don't have questions. We have questions? Have time for questions while they're setting up?
I was told they are really eager to get in here, but again, Mark will be around, so please do ask him questions outside for dinner or tomorrow. Tomorrow, I hope you enjoyed the first day. Tomorrow we start at 10. The first talk tomorrow is about creating targeted word lists with a new tool that will be released, and it's targeted word lists against Americans. I think that's kind of a nice thing being Norwegian. So I'm looking forward to that talk and that tool as well. Have a great evening, everyone.